Welcome back to a new exercise. We continue throwing balls from buildings, but this time we're interested on finding time, which means we're going to have to solve the quadratic equation once again. So let's have a look. A person throws a ball with a speed of 25 meters per second straight upward from the edge of a 50-meter building. Find the time for the ball to reach the ground. We begin with our cartoon of the choice of axis. We draw our y-axis. Here I draw the ground corresponding to y equals 0. This is the edge of my building. And in this case, the ball will be thrown with some velocity that we call Vy0. The ball will go up, will reach the max point, and then will come down. So we have seen this before. And then we'll hit the ground some time t later. And this is exactly the time that we're being asked to find. The building has a height that we call h, and we know this is 50 meters. Since time is involved, we know that there are only two formulas that involve time. One of them is for the velocity, the other is for the position. Since we're interested on the ball hitting the ground, the position is important, so we use this formula. The position along the y-axis is the initial position plus the initial velocity in the y direction times t minus 1/2 g t squared. The initial position is the height of the building, so this is h. The initial velocity is Vy0, which we also know is 25 meters per second, and everything else remains the same. The question is, find the time for the ball to reach the ground. In other words, find the time for the ball to go all the way up to the max point and then come down and hit the ground. And this we have done before too. When the ball hits the ground means that we impose the y-axis to be equal to 0. So we're saying we want the y-axis to be 0. And since we have all these quantities, we can start plugging numbers. Our equation becomes 0 equal to the height of the building, which is 50 meters, plus the velocity, initial velocity in this case is positive because it's pointing up, is 25 meters per second times t minus 0.5 times g, which is 9.8 meters per second squared, times t squared. And now we can expand this expression, and I will also stop writing the units. This is 25t minus 0.5 times 9.8 is 4.9 t squared. So here is our quadratic equation. We can also rearrange this to make it look more like the quadratic equation. So this can be written as 4.9 times t squared. So I multiply everything by -1, so all signs get reversed. Positive becomes negative and vice versa. And also put in the quadratic term first, so I can identify this as a, minus 25t minus 50. And as a reminder, here is the quadratic equation and the corresponding solution. So this is why I put it in this order, just to make it simpler. So t from here is 1 divided by 2 times 4.9, parenthesis, minus b, which in this case is minus 25, so minus minus is plus. This is positive 25, plus minus a square root of b squared, so 25 squared, minus 4 times a, which is 4.9, times c, which is minus 50. And check the square root. So let's see, this is 1 divided by 9.8 times 25 plus minus, and let's see what this number in the square root is. We have a square root of 25 squared minus, but there is another minus inside with the 50, so minus minus is plus 4 times 4.9 times 50. And this is 40.06, so 40 basically. 40. And as we have seen before, there are two solutions. If we take the minus, we get a negative value, which is not meaningful for us in this case because we started measuring t from the point when the ball was thrown. So we only care about a positive value. So we take the positive solution. So 25 plus 40 is 65 divided by 9.8. 65 divided by 9.8 is 6.6. 6.6. So we can write that the time that it takes for the ball to hit the ground is 6.6 seconds. And here's our solution. Just to summarize, what I have done is I draw the situation and I notice immediately that the velocity is positive and is pointing up. And then the ball will reach the max point and come down and hit the ground. For the solution, since we have accelerated motion, we have three possible formulas that we could use. One of them doesn't involve time, which is useless here because we're being asked about the time. And out of the other two, one of them is about the velocity, which we're not being asked here. So that leaves us only with one formula, which is the one that I wrote here on top. And then we plug all the numbers. Since all the units of length are in meters and all the units of time are in seconds, I can simply remove them. This is what I did in this line here. I simply wrote the numbers. I didn't write any unit. And this is because I know that the consistency of the units will be preserved by the equation, so that the time that I find will be in seconds. And after this point is just algebra. I solve the quadratic equation using the formula that we have up here. And the final step is choosing the proper solution, either the positive or the negative. The positive solution is the one that we're interested in here because we care about positive values for time. So we pick that one. And then we just plug the numbers in the calculator. And we find that the time that it takes for this ball to go all the way up to the max point and go down and hit the ground is 6.6 seconds. The next exercise is going to be about dropping objects again, but we will have a nice twist because it's going to be out of this world. So don't miss that.